Here we will continue the chain rule derivative concept. We'll see more example. The first one is, let's differentiate the following with respect to x. We have a function y. You can see the characteristic of the second formula derivative. Here you have the bracket. You have a function inside the bracket with the power of 8. So what to do? We already defined that this is using chain rule, and what we need to substitute is the inside function in the bracket. Suppose this is u, the 3x cubed plus 4x squared plus 6x, and then if we derivate du dx become, don't forget, this is jump down, multiply by 3, we have 9x squared, 4 with 2, we have 8x, and then from 6x becomes 6. Here we can derivate the function u with respect to x. After that, in the bracket, since it is supposed to be u, then what we have now is u to the power of 8. This is the power. Since the function is y and the variable is u, so that we have dy du, which is 8u to the power of 7. Yeah, the power here is 8, 8 is jumped down, and the power decrease 1 becomes 7. So now, after doing the single derivation, we chain them together in chain rule. Here, dy dx will be dy du times du dx. So we copy dy du is 8u to the power of 7, and the du dx is 9x squared plus 8x plus 6. After that, the next step is substitute u back. So we have 8, this is the original function of u to the power of 7, multiply with 9x squared plus 8x plus 6. Since it is the 7th power, so you cannot multiply it by 8, but 8 can come in here, so we have it like this. Yeah, this is the end result and the answer of derivation at example 1. Now if you see the pattern, in general, what we have in the second derivative is, the second derivative formula is y equals a times something in the bracket which we substitute become u with the power of n. So if you compare to the first formula, what you have in the first formula is y equals a times x, not u, to the power of n. So now since x is changed become u, which is a function in x, what we will have is, you put the n down, multiply with a, times n times u to the power of n minus 1. So far it is exactly the same as the first formula. So what is the difference is, since u is a function of x, so you will still need to differentiate u with respect to x. Yeah, you will multiply it with du dx. So that for the chain rule, the concept is, one more time, you multiply a with the power n, and then the u will be having the power subtracted 1, and then please don't stop here. Since you know that u is a function of x, so you have to multiply it with the u prime or du dx. Yeah, so this is the shortcut to the second formula of chain rule. So that if you have x squared plus 1 to the power of 5, you also can make a shortcut like this. Here, the u to the power of 5, then if you put the power down, you will have 5. This is the power instead of having 5. Now the function which is still there, x squared plus 1, will be having the power of 4. And then after that, don't stop. Yeah, this is like first formula, but since we have x squared plus 1 inside the function, you will multiply it with the inside function derivation. This is du dx, which is coming from the 2 multiply with x from x squared, and then 1, derivation of 1 is 0, so you cannot see it here. Yeah, so this is the shortcut if you want to use this formula instead of multiply it 1 by 1. Yeah, make sure you got it, make sure you know the concept first. Okay, so let's see if we are using this formula. Then if we have y equal square root of 8x cubed plus 7, if you want to derivate, you make the power become a half first. And then let's see what we do. Here we have a half coming from the power, and then a half is multiplied with the u, 8x cubed plus 7, and now the power is subtracted 1. From a half, subtracted 1 become minus a half. And then where is the 24x squared comes from? It is coming for 8 times 3, the inside function derivation. 8 times 3 is 24. The x now having the power of 2 instead of 3. Yeah, this is coming from 3 minus 1. And then the 7 is gone, so you have only 24x squared for the inside function derivation. So you can simplify it like this. Multiply a half with 24x squared instead of the minus a half power. Okay, so you can change it back later since it is minus, so it is at the denominator and the power is a half becomes square root of, yeah? So you can write it down like this. Okay, next at example 3 we will see the application, yeah, of the second derivation formula. Calculate the coordinate of the point on the curve y equal 1 minus x to the power of 4 at which the gradient is minus 4. Gradient here is talking about dy dx. So we know that dy dx is minus 4. So to connect it with y, so from y we make dy dx. Look at here, we use the chain rule formula. First you put 4 down, and then the u still will be written, and the power will decrease 1. From 4 become 3, and then minus 1, where is it coming from? Yeah, don't forget you have u inside here. When u is derived, u dx become minus 1, coming from minus x, yeah? Minus x become minus 1, 1 is gone. The derivation is 0. So this is dy dx function, which value is minus 4. Yeah, we can simplify dy dx become like this and equate it to be minus 4. So when it is minus 4, then you can have you can cross it, and 1 minus x cubed become 1, so that 1 minus x is 1, x is 0. So this is x coordinate of the point where the gradient is minus 4. If you want to calculate the y, don't forget to substitute it here, right? Y equals 1 minus 0 to the power of 4, so y is 1. So that is the coordinate of the point at which the gradient is minus 4. Okay, that's all for today. Thank you for watching the video. Please watch it again and again if you still cannot get it. God bless you all, and don't forget to be safe. Bye bye.